This lesson helps you understand quadratic equations. The lesson explains the relationship between a quadratic equation and a quadratic function, and shows how to solve a quadratic equation by graphing. In a previous lesson, you learned a quadratic function is defined by a second-degree polynomial equation, y equals ax squared plus bx plus c. The graph of a quadratic function is a smooth, symmetric, arc-shaped curve called a parabola. The line that divides the parabola in half is the axis of symmetry. The point where the axis of symmetry intersects the parabola is the vertex. If you start with a quadratic function and set y equal to 0 and turn it around, you get the quadratic equation. Ax squared plus bx plus c equal to 0 is the standard form of a quadratic equation. This lesson and the following lesson helps you understand quadratic equations and how to solve them. For this quadratic function, the related quadratic equation is negative x squared minus 2x plus 3. It has two solutions. If you substitute x equal 1, you get negative 1 squared minus 2 times 1 plus 3. Negative 1 squared equals negative 1, and negative 2 times 1 equals negative 2. Then negative 1 minus 2 equals negative 3. And you have negative 3 plus 3 equal to 0, which is a true statement. So x equal 1 is a solution to the equation because it's a value of the variable that makes the equation true. If you substitute x equal negative 3, you get minus negative 3 squared minus 2 times negative 3 plus 3. Minus negative 3 squared equals negative 9. And minus 2 times negative 3 equals positive 6. Then 6 plus 3 equals 9. And you have negative 9 plus 9 equal to 0, which is a true statement. So x equal negative 3 is also a solution. So here's the quadratic function, its related quadratic equation, and the solutions to the equation. Notice the solutions are equal to the x-intercepts of the function. One of the solutions is x equal 1, which matches the x-intercept at 1 on the x-axis. The other solution is x equal negative 3, which matches the intercept at negative 3 on the x-axis. It's easy to understand why this is true. A solution to the equation is a value of x that makes the expression equal to 0. Since this expression is the function, a solution is a value of x that makes the function equal to 0. And the function is equal to 0 at its x-intercepts. Notice the y-coordinates of the intercepts are 0. So the solutions and the x-intercepts are the same. And this is true of all quadratic functions. The relationship between the solutions to the equation and the x-intercepts of the function also tells you something important about the number of solutions of a quadratic equation. The vertex of a quadratic function can be located in one of three places. It can be below the x-axis, It can be on the x-axis, or it can be above the x-axis. So if the graph of the function opens upwards, the function can have two x-intercepts, one x-intercept, or none. Therefore, since the intercepts and the solutions are the same, when you're solving a quadratic equation, you can expect to have two solutions, one solution, or none. So one way to solve a quadratic equation is to graph the related function. Here's a quadratic equation, x squared plus 6x plus 8 equal to 0, and its related function. To begin with, since the leading coefficient is positive, the graph opens upwards. Next, use the formula to find the equation of the axis of symmetry. The linear coefficient b is equal to 6, and the leading coefficient a is equal to 1. So you have negative 6 over 2, which is negative 3. And the axis of symmetry is the vertical line x equal negative 3. So draw a vertical line through negative 3 on the x-axis. Since the vertex is a point on the axis of symmetry, x equal negative 3 is also the x-coordinate of the vertex. So to find the y-coordinate of the vertex, evaluate the function for x equal negative 3. Negative 3 squared equals 9, and 6 times negative 3 equals negative 18. Then add 9 and 8 for 17. Finally, you have 17 minus 18 for negative 1. So the vertex is a point at negative 3, negative 1. Next, graph the y-intercept. The y-intercept is always the same as the constant term of the equation, which for this function is 8. So graph the y-intercept at 0, 8. Since that's 3 units to the right of the axis of symmetry, there's another point 3 units to the left. Finally, calculate at least one more nearby point. Select a value of x anywhere close to the vertex, like x equal negative 2. Then evaluate the function for x equal negative 2. Negative 2 squared equals 4, and 6 times negative 2 equals negative 12. Then 4 plus 8 equals 12, and 12 minus 12 equals to 0. So there's a point at negative 2, 0. Since this point is 1 unit to the right of the axis of symmetry, there's another point 1 unit to the left. Now draw a smooth curve through the points, and you have the graph of the function. You can see from the graph the x-intercepts are at negative 4 and negative 2. So returning to the related equation, the solutions are x equal negative 4 and x equal negative 2. Be sure to check the solutions. To check the solutions, begin by substituting x equal negative 4 into the equation. Then negative 4 squared plus 6 times negative 4 equals 16 minus 24. And 16 plus 8 equals positive 24. And since 24 minus 24 equals 0, the first solution checks. To check the second solution, substitute x equals negative 2 into the equation. Negative 2 squared plus 6 times negative 2 equals 4 minus 12. And 4 plus 8 equals positive 12. And since 12 minus 12 equals to 0, the second solution checks. So to summarize this lesson, one way to solve a quadratic equation is to graph the related function. The x-intercepts of the function are solutions to the equation. This lesson explained the relationship between a quadratic equation and a quadratic function, and showed how to solve a quadratic equation by graphing. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.